Assignment 6-4. Let me just get there. Where are we at here? Oops. Here we are. So assignment 6-4 was the ability to find the area between curves and two curves. So can you find the area between two functions? So the integration of that set, which may be positive, negative, zero, however, if you're asked to find an actual area, that area cannot be negative. So the key here is, for this lesson, is you take the above, subtract the below. You'll say it over and over again. Above, subtract below. Top, subtract bottom, or right, subtract left. So that's what we're going to practice for our assignment. And then it's the average value of a function connected to it. Okay, so for problems 1 and 2, we're going to set up integrals that could be used to find the areas that you see, but we're not going to integrate it. We're just going to do the setup, and then show the equations used to find the limits of integration to it. So to find the limits, we might have to set up a system to find the limits. So if I look at number 1, the first thing I need to recognize is negative x squared plus 2. That's a parabola folding down. So which one's higher and which one's lower? So I need to recognize which each system is, or which each equation is. So first of all, if I want to find the area, the lower limit, the x value, is negative 1. And the x value of the upper limit is 1. So I'm going to go from negative 1 to positive 1. So I'm going to integrate negative 1 to positive 1. And the formula is simple. It's top, subtract bottom. But I need to know which one's on top. So the one on top is g at x, which is negative x squared plus 2. And then I'm going to subtract the bottom, which is x to the exponent 2/3. And that's it. That is the setup. So let me show it to you. And then we can put parentheses around all of it and dx. Perfect. So that's good. That's a good pattern in practice to do. And that's it. So the lower limit to the upper limit, the top, subtract the bottom, use parentheses so you don't make a mistake there, and it's all good. And don't forget the dx. Number 2, let it be simple to begin with. Here, I'm not given all the information I need. So when I look at the lower limit, I can see the x value of the lower limit's probably 0. And for the upper limit, man, I'm not given any information. So in order to find the limits, I need to make them equal to each other and find the points of intersection. So how do I find where they intersect? Is I make them equal to each other. So that's what I'm going to do first. So x squared subtract 4x equal to negative x. Make them equal to each other so you can see where they intersect. This is using, it's using substitution to solve a system. So make them equal to each other. Hope you can see that. Yeah, that's better. And then solve it. So it's a quadratic equation. I'm going to add x to both sides. Now I'm going to factor it. So first make it equal to 0. It's a binomial, so I'm going to factor out an x. That's it. Not a diamond. And then what are the solutions? So x by itself is 0. X subtract 3. The solution is 3. So those are my limits. So that's step 1. So I said I saw the first one. The lower limit is 0. I didn't know the other one. So now I found the other limit, and it's 3. So here's the setup. I'm integrating now from 0 to 3. I didn't know it. I had to actually do algebra to understand the limits. Now, I'm going to do this to begin with. I'm going to do parentheses, parentheses, big parentheses, and then I understand that this is the top, subtract the bottom. That's what I understand. So can you set it up correctly and then just plug in the top function and plug in the bottom function? So for this one, if I look, which one of these, and it's not labeled, you need to know, the one on top is the line. So which is that? Well, that's negative x. The one on the bottom is the parabola. Well, that's x squared, subtract 4x. You're not going to be told this one's on top, this one's on the bottom. You have to know your graphs and know, oh, the line is on top, the parabola is underneath, identify it, and then subtract. So that's what it looks like. I don't need to simplify that. But that's the pattern that I'm going to use with parentheses. So I'm going to set up the pattern and then plug in the top, plug in the bottom, and then let it go. Number 3. In number 3, it says, for problems 3 and 4, show equations used to find the limits of integration. Show limits are the bounds. Show integral setup, and then find the areas at the end. So I'm going to do everything from beginning to end. So my goal is to find the area of that shaded spot. To do that, I first need to know the lower limit and the upper limit. How do I do that? I take the two functions and make them equal to each other and solve for x. So to solve this, it's a quadratic. I don't want my quadratic to be negative. So I'm going to add x squared, subtract 4x, and then 3 stays positive. So I want to make my quadratic term positive. This is a diamond. It's a trinomial. So the two numbers that multiply, and it's easy. So don't make this like really a long question. So the two numbers that multiply to 3 and add to -4 are -1 and -3. They multiply to 3, they add to -4. So what are my solutions? So from x subtract 1, the solution is +1, x subtract 3, +3. Those are my limits. Okay, so next, I'm going to integrate from where to where? 1 to 3. Next, what am I going to do? I'm going to take the top, subtract the bottom, put parentheses around all of it, dx, and then remember and remind myself that it's top, subtract bottom. So now go back to the graph. The top is the parabola. That's 4x subtract x squared. The bottom is the horizontal line, which is 3. So the first step, again, top, subtract bottom. So my first step was to find the limits. And then we go top, subtract bottom. That's the setup. Now the next step is to actually find the area, to actually do the calculus now. So now I am going to simplify it. So I have 4x subtract x squared, order doesn't matter, subtract 3. So I simplified within it. And then I'm going to integrate each one. Now how do you integrate again? These are simple power rules. What does that mean? You add 1 to the exponent and divide. You add 1 to the exponent and divide. And -3 would just be -3x. And I'm integrating from 1 to 3. We're not going to simplify it at the end. All I'm going to do is plug in 3. So step 1, I plugged 3 in, put parentheses around it, subtract. Now what do you plug in? So the upper limit, subtract the lower limit. And try not to simplify it. Allow it to be just like that. The upper limit, subtract, and that's a perfect answer. If I had a calculator, I would have just typed this thing in to begin with. So I could just use a calculator at the very beginning and not go through all this. But without a calculator, that's the answer. This is the area of that part that you're looking for, and you don't need to simplify it. Number 4. In number 4, it says use a calculator. So I'm going to set it up and use a calculator. So the calculator doesn't help me until I actually set up the integration. But once I set up the integration, I'm still using my calculator. If I have battery power, which I hope I do. Here we go. So step number 1 to use a calculator is I have to find my upper limit and my lower limit. And I need to make them equal to each other to begin with. Well, as soon as I make them equal to each other, well, I'm in no mood to solve that by hand. If I'm going to use a calculator, I'm going to use a calculator. So I'm going to make them equal to each other. There it is. Do you want to solve that? So we're going to use our calculator to solve it. I think the answer is no. So we're going to use our calculator to solve it. And so I'm going to press menu, then algebra, and then I'm going to press solve. And I'm just going to type it in. 2x subtract x squared equals, and it's negative the cube root. Now, cube root is in blue, right? Let me see it. Not yet. So it's in right there. So do you see it's in blue there? The n and the radical x. That's where I'm looking at. So I'm going to go control, and that's what it looks like. And it's cube root of x. Move the cursor, subtract 1. So can you type that in? Then you have to tell the calculator to solve for x. So you got to go comma. That's on the bottom left. So under the pi, on the bottom left corner, is a comma, and then x, which is on the bottom of your calculator. And that's it. Control Enter. And those are your solutions. So can you tell how you didn't want to do that without a calculator? So what's your lower limit and what's your upper limit? So now we can get started. So approximately it's point. And the challenge here is we don't really want to round before the question's over. So I'm going to have a few decimals here. So, I mean, I don't really want to round too much. But you get the idea. What I'm going to try to show here is you can highlight the number and save it. See if I can do it. So what I did was I pressed enter again and it went down below, and then I hovered over it and I double clicked on the number. If I go control, what's copy? C. So control C, it will copy it in. So when I go down here, so I've already copied it. So when I go and I want my setup, so when I do the setup, which is menu, calculus, and integration, which is 3, my lower limit, I'm going to go control V, and it'll paste. And then you'll have the exact lower limit. Can we try that again? So we're going to go up to the second answer. And I'm going to take the cursor to the second answer. See it right here? And I'm going to double click on it and highlight it. I'm going to go Control C. And then I'm going to move the cursor down here and then go Control V and paste it in. That way I have the most accurate answer. So it's essential that we know how to copy and paste the full numbers in if it's in the middle of the question. Okay, this part we haven't done yet, so I'm going to set up the next part in a moment. So here, I did the first part. That's the integration. Then I need to know what's top, subtract, bottom. So for number 4, can you tell that the top is the parabola? So that's 2x minus x squared. And then the bottom is negative and the cube root of x. Negative cube root of x, subtract 1. All right, this is what it looks like for the setup, and then I'll show you with the calculator. I just double-checked my calculator that when I put it in there, this should be a negative. For some reason, when I double-clicked, the negative wasn't a part of it, so I need to make sure it goes from negative 0.192 to positive that. And when I looked on the graph, it confirmed that the lower limit is a negative x value, just to the left of the axes. Anyway, this is the setup. So now I'm going to type that in the calculator. So move the cursor to the box. And then we're going to type in parentheses, 2x subtract x squared, subtract parentheses, negative the cube root of x, move the cursor, subtract 1. Just double check, did you type it in correctly? All the signs are right, the radical sign, it's not, like everything's typed in good. And then make sure at the end we're integrating with respect to x. That's all set up now. Control Enter, and you have your answer for the area. So for number 4, now you round to 3 decimals. So the area is 6.356. So now, at the very end of the problem, then you can round to 3 decimals. Otherwise, we need to copy paste. Honestly, on the AP exam, if you wrote it to 3 decimals, like on paper, but yet you copy pasted, because if you didn't copy paste, you'd be off by a number or 2 here. All right, number 5. In number 5 and 6, sketch regions bounded by the graphs on the given equations. Show equations used to find the limits of integration, and show integral setups and find the areas. So number 5, you get to use a calculator, which is good. So step 1 is, I got to find my limits. So I'm going to take the 2 equations and make them equal to each other and use my calculator. There it is. So I'm going to guess press menu solve or menu algebra, then solve, and I'm going to type it in. So 3 to the exponent t equals, and it's the square root of t plus 2. Move the cursor, comma, t, and then control enter. So those are my upper and my lower. So, and I want that to stay in my calculator so I can copy paste if I need to. So approximately it goes from a negative 1.987 and then the upper bound is 0.398. And again, I'm going to copy paste when I do it. Now, what's going to be my upper and what's going to be my lower from that? Let's use our calculator to graph this so you can see it better. So I'm going to graph. You can also press the shaky calculator button. Now, I want to do a standard view. So I just want like the window to be a standard, that's number 5, just so you can see it in terms of that. There's already something there, so I'm going to press tab and I'm going to go back and I'm going to erase that, whatever I had before. Oops. There we go. Okay, so I'm going to now just type in 3 to the t, but it doesn't like the variable t. So we're going to go 3 to the exponent x, just that one. So do you see 3 to the x? Press enter so you can see it. So do you see that there? I'm going to, and so do you see the curve of 3 to the x? Then on the same graph, press tab again. I'm going to type in the square root of x plus 2. Press that. Now look at this next one. Now when you actually see the 2 graphs, one's blue and the other one's red, can you tell which is above and which one's below? And I think you can tell that the one that's above where they intersect is red and the one below is blue. That helps. So when I look here, the red, which is the square root, is actually the one above. That's the square root of t plus 2. Subtract 3 to the exponent t, all parentheses, dt, because that's the variable. And then that's what I would type in my calculator. So from here, I can press the shaky calculator button again. That's that toggle calculator button right there. Just press that. It goes back and forth. And then I'm going to press menu. I'm going to press calculus, and I'm going to press integration. And then my lower limit, I'm going to go here and then use my cursor. Move the cursor here. And I'm going to double, oops, I'll try it again. I'm going to double click on that. There it is. That's my lower limit. Notice how the negative didn't get included. So I got to be careful with that. So I'm going to go Control C. I'm going to move the cursor down here. I'm going to put a little negative first and then Control C, because I noticed it didn't include the negative. Oh, Control V. Oh, I think I might have screwed that up. Oh, no. Okay. Good. So Control C, copy. Control V, paste. You probably know that way better than I do. And then the second one, it's a positive number, so I don't have to be too careful. Double click it. Control C. Move the cursor here. Make sure it's right there in the upper box. Now go Control V. And there they are. You need to have that skill to copy paste. And then what goes in here is parentheses, and it's the square root of t plus 2. And then move the cursor, subtract, parentheses. Actually, you don't even need parentheses with that one. 3 to the exponent t. See how it does the parentheses for you, and then dt, like you're integrating with respect to t, the variable that you're integrating with. So double check, did I type it in correctly? Control Enter. What's the, now you round to 3 decimals, and I get 1.167. I'm going to show you a second way. So I get that. Remember, you can go 3 numbers after the decimal at the end of the question. You don't even have to round it to 8. Like, that's a good answer. All right, what's the second way I can do it? It is what it is if you don't want to see it. The second way to integrate is directly off the graph. So if I look at this graph and I realize I kind of want to zoom in just a little bit. So if I change the window so I can really see the intersection better, I'm going to do my own window settings just for the X. So let's say, like I know if I want to see it well, like -2 to +1, that will allow me to see it. Let's see how that looks to begin with. The Y is a little bit big. Menu, window. I don't need such a large Y value here. So when I plug it in, I think that's a good window there. So you can see the window pretty good right there. And that you can see the red is above the blue. How do you integrate off the graph? Is you press menu. And then do you see the analyze button, number 6? And then you can see bounded area. That's number 8. And then it says, what's the lower bound? You can actually type it in. Now, this one's not as accurate, 0.398. You can... So you can type in 0.398. Oh, let me try that. Let's just go back. So let's try it again. Menu, analyze, the bounded area, which is 8. So I'm just going to press enter. Press enter. Did it do it? I'm not doing this very well. Let's try it again. So we have our graphs. Menu. Analyze. Bounded area 8. So the lower bound I'm going to type in -1.987. enter. And the upper bound, I'm going to type in 0.398. So I just typed in the numbers I wanted, and then you could see the answer is 1.16. Same answer, right? So off the graph, you can actually see the shaded area, top, below, bottom, bounded area. And then we can also do it this way and get the same answer. Something to practice so that you can be efficient with it or not right now. All right, number 6. So for number 6, it says no calculator, and it says write as a functions of y. In other words, isolate x. So you have x equals y squared subtract 3, and you have y equals negative 1/2 x, and I want to find the area trapped between those two curves. Let's go through that. So it said don't write it as in y equals. Instead, write it as x equals. So we have x equals. This one, can you solve for x? We're going to multiply both sides by negative 2. So that negative 2, the negative 2 and the negative half cross out. So x is equal to negative 2y. X is equal to y squared subtract 3. So then we can take the 2 and make them equal to each other. So we have y squared subtract 3, negative 2y. We're going to make them equal to each other, and we're going to solve it. So it's a quadratic. We're going to make it equal to 0. So we're going to add 2y to make it equal to 0. It's pretty simple to factor. The two numbers that multiply to negative 3 and add to 2 would be plus 3 and negative 1. They multiply to negative 3 and add to 2. So the two solutions, the bounds, would be negative 3 and positive 1. So that's my lower bound and my upper bound. It just happens that the graph is sideways. So if I understand the bounds here, it goes from negative 3 to 1. But now we're finding areas sideways where it's right to left. So we're now going to use this y squared subtract 3 and negative 2y. So those are the ones. It's going to be looking in terms of y instead of x. So I want to graph these. So how would I graph them? Well, I already have 2 points of intersection right there. So if y is negative 3 and 1, this is what the graph would look like. So if you had y squared subtract 3, you know what the line looks like. So negative 1/2 x is right here, 0, and then you go down 1 and to the right 2. So there's your line, negative 1/2 x. And then we have a sideways parabola that's intersecting at negative 3 and positive 1. So let's get that. So negative 3 is down here and positive 1. And then you can get a sense of the curve of it. And for this one, we're going to use the y values. So there's like a sketch of it. So y squared subtract 3, this is like negative 3 over here is the vertex, negative 3, 0. It's a sideways, that's the shaded. What's on top and what's underneath? So on top is negative 1/2 x. Oh, but we write it in terms of y. Sorry, so the top is negative 2y. Subtract the parabola, which is y squared subtract 3. And that's in terms of y. And again, it's not on top. So it's the right subtract the left. So what's on the right side and what's on the left side? So when it's sideways, we need to have the skill, instead of top subtract bottom, it's right subtract left. So on the right compared to on the left. Now, all we have to do is integrate it and plug in the upper lower bounds. We don't need to simplify the answer at the end. So here's our setup. There are no like terms here. Just be aware that subtract sign also belongs here, so it makes it a plus 3. So if I integrate this, you add 1 to the exponent and divide. If I integrate the next one, add 1 to the exponent and divide. And again, a negative makes it plus 3. So that's why it's plus 3y. And we're integrating from negative 3 to 1. Now the last step is just to plug in the upper bound and then the lower bound and subtract. So this is what it would look like. So you have negative 2y squared over 2. The upper bound, which is positive 1. And then put parentheses around it, and then subtract the lower bound, and just write the same thing in. Oops, I didn't need a y in there. Sorry. So it looks like that. So negative 2. So now the lower bound, negative 3. And there's the lower bound. So here, so you can see the whole thing. So don't feel like you need to simplify it. So first you plug in positive 1, and then you plug in negative 3, and then subtract them, use parentheses, and it's over. So that you can quickly understand the pattern, the structure, and it's done. All right, I'm going to end right there for number 6, and then I'm going to come back and do the second half of the assignment on another video. Mr. G Math, over and out. I'm proud of you for doing your work.